Hello, Chem 2 students. Mr. Keister here with you again today. This is the video for Monday, October 12th, 2020, which is our scheduled 37th day of school for the fall semester. Always keep in mind, though, that the dates could change for a variety of reasons, but the lessons and the order of those lessons will remain the same regardless. So let's take a look at the do nows, see what today's schedule is. You're going to pick up an additional review. We got a test coming up tomorrow. I thought you might want to do this just to keep fresh with all the information you were presented with this unit, because as there was a ton, as you know. Your homework for today was to complete 1 through 13 only on electron configuration. Hang on to that. We're going to do a quick lesson to finish that up, and then you will finish that assignment and turn it in today before you leave. Let's see, you were also to begin working on your Unit 3-1 exam review. Hopefully you have nearly all of that done. You should have been able to, except for the very last section. Also, the additional quantum mechanical model review that you picked up today will be an excellent additional practice over this material that's going to be on tomorrow's exam. I would strongly, emphasis on strongly, suggest that you do it too as a part of your review. So today we're going to finish a quantum mechanical model. We're going to finish up with electron configuration and see how noble gas configurations are written. Hopefully after this past week or so, it has all come together for you as in regards to the modern atomic model. We're going to finish the assignment that we started yesterday. It's due today by the end of the period, so you will be turning that in for a grade before the dismissal bell rings. You also need to finish your Unit 3-1 exam review. Although it's technically due today by the end of the period, of course, I won't be collecting it until tomorrow on exam day. However, if you have it done today and want to check it, let me look it over real quick, and then you can check it with the answer key. Otherwise, you can check that key tomorrow morning at 7 a.m. It'll be posted on the board here at school. It will also be posted in Canvas on the answer keys page. So let's get our lesson out of the way, and then I will come back and run a separate little video on the review for tomorrow's exam. So let's move forward with today's lesson. So yesterday we diagrammed the electrons in regards to electron configuration, all right, which plays right off of the orbital notation, actually. So today we're going to learn about noble gas configurations. This is a shortcut method to writing an electron configuration that involves using a noble gas, or group 8A of the periodic table, which includes helium, neon, argon, krypton, xenon, radon, and the newest element, 118, oganesson. So let's take a look. Let's move this up, and then let's take a look at a regular electron configuration, and then see how we translate that to a noble gas configuration. So let's choose selenium, all right? So selenium is number 34. So again, if we follow the diagonal rule, hopefully you're able to reproduce that diagonal rule, or you can pull it straight off the periodic table. As I said, it's periodic table is laid out in order, row to row, left to right, by the diagonal rule, by the orbital filling rule, all right? So selenium has 34 electrons. So we start with 1s2, 2s2, 2p6. That gets us to 10. 3s2, 3p6. That gets us to 18. 4s2, 3d10. That gets us to 30. And then 4p is next, but we don't need all 6. We only need 4. And if you look at selenium's position on the periodic table, I'm looking at it right over there. It's the third row down in the P block, which is 2p, 3p, 4p. Remember, the P block doesn't start till energy level 2. And it is then the fourth one over, which is 4p4, which is exactly how we ended it here. So everything looks good. The superscript numbers all add up to 34 as they should. So again, 2 ways to double check that you did that correctly. All right, so noble gas configuration. Find the noble gas closest to the element you want to write an electron configuration for. but it must be the one that has fewer electrons. So look on your periodic table and see where selenium is, all right? 4p4. If you go directly to the right of that, you'll get to krypton. But krypton has 36 electrons. That's too many. So we got to go one back above that, in which case that would be argon, all right? Write the chemical symbol for the noble gas in brackets with its atomic number above it. So this is argon, number 18. By doing that, we have taken care of the first 18 electrons. And if you see, argon ends in 3p6, and so we are already from the beginning to right there where 3p6 is. All right, we've already taken care of that right there. So now we will continue on. So what comes after the 3p6? All right, well, next is 4s2. Next is 3d10, and finally 4p4. So we have 2, 12, 16, and 18, 34. We got it, all right? So we found the noble gas closest to our element, but has fewer electrons. That is argon, all right? Check the location of our element. See what it should end with, 4p4. We got that right there. Check the diagonal rule and fill in the missing orbitals between the noble gas you started with and your element's ending orbital, which is what we did right there. All right. Our noble gas ended with 3p6. We picked up with 4s2, 3d10, 4p4. Adds up to 34 as it should. We're good. All right. So let's look at a few others and do those. All right. So start with sulfur. All right, so sulfur is number 16. Take a look at your periodic table and see where sulfur is. There it is in the P block again. Second row down, fourth one over. All right, actually it's right above selenium. So if we go straight to the right, we get to argon for a noble gas. That's too big, so we go back one. So that would be neon. So we're going to put neon in brackets. Put its atomic number above it, which is 10. All right, so neon ends in 2p6. We're going to go on from there until we get to sulfur. So after 2p6 is 3s2, and then we go to 3p, which is where sulfur is located in the 3p row, and it's the fourth one over. So that is 3p4. So we have 10, 12, and 4 is 16. We're ending at 3p4, which is where sulfur's location is on the periodic table. P block, fourth one over, second row, which is 3p row. And so we're good. Next one is calcium, which is number 20. All right, so if we go to the right, calcium, our noble gas is krypton, but again, that's too big. So we're going to go one before that, which is argon. Put that in brackets. And number 18, 18 electrons above that. We only need 20 electrons total. We only need 2 more. All right, so argon ends in 3p6. All right, look at its location on your periodic table, 3p6. What orbital's next? That would be 4s, which is right where calcium is, actually. And it is 4s2. And there we have it. There's our 20 electrons. Calcium's position is 4s2 on the periodic table. Fourth row down, s2, second one over. We got it. 10, number 50. So 10, where is 10? There it is. It's over in the P block, all right? So if we go to the right of 10, we get to xenon, but that's too big of a noble gas. We need smaller than that, so we're going to use krypton. Krypton is number 36. So krypton in brackets, 36 above that. Okay, so krypton ends in 2, 3, 4p6. We're going to go on from 4p6. After 4p is 5s. 5s2. That gets us to 38. Then next is 4d. 4d10. That gets us to 48. We only need 2 more. So after 40, 10 is 5p, and as I see where 10 is located over there, it's 2, 3, 4, 5p2. 2 and 10 is 12, 2 is 14, and 36 is 50. We're ending on 5p2, which is 10's location on the periodic table. Got it. And finally, the last one is gold, number 79. All right, gold's there in the D block. All right, we'll go to the right of gold. You get to radon, but that's too big. So we're going to do xenon, which is number 54. So if you look at xenon's location, we got 2p, 3, 4, 5p6. All right, xenon ends 5p6. We're going to go on from there. What goes after 5p? That would be 6s2. That gets us to 56. What's after 6s? That would be 4f. All right, 4f's in there, remember? 4f14. That gets us to 70 electrons. We only got 9 more to go. Next after 4f, is 5d. Remember, the D block begins with 3d, 4d, and gold is in the 5d. It's the 9th one over. Next to the last one, 5d9. We do our math, 54, 56, 70, 79. That adds up. Gold is in the 5d9 position. That matches up. So we got it. All right. This is noble gas configuration. All right. Shortens things up a bit, especially on the larger elements. Saves you a little bit of time. On the smaller ones, maybe not so much. But certainly on the larger ones, it does. All right. But you have to be able to do normal electron configurations as well, in addition to which will then help us to learn how to do noble gas ones. Okay. That's the end of the lesson on the quantum mechanical model. We've hit it. We've done it. All right. So you are to finish the assignment we started yesterday over electron configuration. You're going to do the back side of it. You will get that done. You want to check it? That's fine. Let me see your paper real quick. I'll let you check the key. And you will turn that in before the end of class today. So turn it in before the dismissal bell. If you are at home, you need to submit that to me by the end of your regularly scheduled class period. So make sure you submit it to me electronically by that time. That's when it's due. The rest of the time we have in class today, you can work on your 3-1 review. I'm going to come back in just a second, do a little separate video as far as reviewing for the test, which is tomorrow. All right, it's a big one, a lot to know. We've covered a lot of material. I hope you've been studying already before now. So we'll get to that video here shortly. So until then, this is Mr. Keister signing off. Stay safe, everyone. Take care. Stay focused and work hard. Got that exam tomorrow. I'll be back with you in just a little bit. We'll talk about the exam. Take care, everyone.